In a limestone quarry in Baalbek, Lebanon, lies a cut stone block measuring 27 meters in length. In 2014, a team from the German Archaeological Institute fully excavated its base and calculated its mass. It weighs approximately 1,650 tons. That is the equivalent weight of 4 fully loaded Boeing 747 commercial aircraft. It was carved out of the bedrock by human hands, perfectly squared, and angled to be moved. The standard historical account requires us to believe that this block was intended to be transported by human muscle, wooden rollers, and hemp rope to a temple complex nearly a kilometer away. We know the Romans were master engineers. We know they utilized complex pulley systems, capstans, and immense labor forces. But physics is not a matter of historical theory. It is a matter of friction, tensile strength, and sheer force. To pull a 1,600-ton block across uneven terrain without it sinking into the earth and crushing the wooden rollers beneath it exceeds the known limits of ancient mechanical engineering. The block was ultimately abandoned in the quarry, which archaeologists point to as proof that the builders realized they had exceeded their own capabilities. But less than a mile away, in the foundation of the Temple of Jupiter, sit 3 blocks weighing 800 tons each. They were not abandoned. They were raised 7 meters into the air and set into a retaining wall with joints so tight a razor blade cannot be slipped between them. No one has fully explained how. Mainstream archaeology provides a specific, documented explanation for Roman lifting technology. The Roman architect Vitruvius described complex cranes powered by treadwheels, where multiple men would walk inside a large wooden wheel to generate lifting force. This is a proven, historical fact. Roman engineering was highly capable, and they regularly moved obelisks, weighing over 300 tons, using barges and human-powered capstans. The Orthodox defense argues that the blocks at Baalbek were moved using exactly these methods, merely scaled up. But this is where the physical evidence tests the limit of the theory. A wooden treadwheel crane has a maximum structural load. Beyond a certain weight, the timber snaps and the ropes shear. Modern crane companies, using tracked hydraulic crawlers, forged steel cables, and computerized load balancing systems, require months of site preparation to lift an 800-ton object. No experiment using the wooden tools available in the 1st century has successfully produced a lift of an 800-ton block to a height of 7 meters. Before we continue, if this is the kind of evidence you've been looking for, subscribe to the channel. Every video here takes one documented anomaly, one object, one measurement, one finding that the standard account cannot fully explain, and follows the evidence wherever it goes. No fabrication, no alien conclusions, no invented measurements, just what the physical record actually shows. Understanding what ancient civilizations actually built requires us to look at the raw physical data, stripping away both modern assumptions and fabricated myths. Leave a comment. Which of these 5 structures do you think exposes the largest gap between the official archaeological explanation and the physical reality of the object? In a future investigation, we will examine an ancient maritime mechanism recovered from a shipwreck that calculates celestial movements with a precision Europe would not achieve for another 15 centuries. Now, back to the evidence. 9 and a half thousand kilometers away, high in the Andes of Peru, lies the megalithic fortress of Sacsayhuaman. Constructed by the Inca Empire in the 15th century, the site features zigzagging terrace walls built from massive andesite and limestone blocks. The largest of these stones are estimated by UNESCO to weigh between 100 and 120 tons. But it is not merely the weight that defies expectation. It is the geometry. The walls are built using polygonal masonry. The stones are not cut into uniform rectangles. They are irregular, multi-sided shapes, some featuring up to 12 separate angles. They lock together without a single drop of mortar. The joints are so meticulously crafted that they have survived centuries of devastating Andean earthquakes, the stones shifting and then settling exactly back into place. The official archaeological explanation is that the Inca shaped these stones using river cobbles to pound the edges, hoisting them onto earthen ramps to test the fit, and then lowering them back down to scribe and grind the connecting surfaces until they matched perfectly. Here is the counterintuitive reversal. To perfectly scribe a complex, irregular joint, the stones must be brought together. To adjust the fit, a 100-ton stone must be lifted away, pounded with a smaller stone by hand, and then precisely lowered back into place. To achieve the paper-thin, zero-clearance joints seen at Sacsayhuaman, this process of lifting, checking, and lowering a 100-ton irregular polygon would have to be repeated hundreds of times for a single block. We know the Inca did not possess iron tools, the wheel, or written mathematics. We know they used earthen ramps and human labor. But modern stonemasons, using diamond-tipped saws and hydraulic lifts, struggle to reproduce multi-ton polygonal joints with this level of seismic perfection. If the standard tools could not practically execute this repetitive testing process on blocks the weight of a diesel locomotive, what could? Just 350 kilometers southeast of Sacsayhuaman lies a site that makes the Incan fortresses look structurally simple. At an altitude of nearly 4,000 meters in Bolivia, the ruins of Pumapunku sit shattered across the high plateau. Built by the Tiwanaku Empire, the site features blocks of red, sandstone, and andesite, some weighing up to 131 tons. The anomaly here is not merely the weight, it is the material and the cuts made into it. Andesite is a highly abrasive, dense volcanic rock. On the Mohs scale of hardness, it rivals granite. Yet scattered across Pumapunku are the famous H-blocks, prefabricated, perfectly geometric stones featuring right angles, sharp internal corners, and precision-drilled blind holes of uniform depth. The mainstream explanation holds that the Tiwanaku shaped these stones using harder pounding stones, sand acting as an abrasive, and plumb bobs for alignment. They rubbed the surfaces flat over months or years of continuous grinding labor. But here is the physical problem with sand and pounding stones. You cannot pound a perfectly sharp internal right angle into a hard volcanic rock. Pounding tools are round. Abrasion leaves concave, sloping corners. To achieve a crisp, 90-degree internal cut in andesite, where three planes intersect precisely at an inside corner, requires a tool that fits into that corner. Modern fabricators achieve this using diamond-tipped router bits and high-speed rotary tools. At Pumapunku, these sharp internal corners exist. A ruler placed along the recessed channels sits perfectly flush. The drill holes are evenly spaced and completely smooth. No independent replication attempt using copper chisels and pounding stones has produced the sharp internal geometry seen on the H-blocks. If this knowledge of precision stone cutting existed here, isolated high in the Andes, how many other places possessed it? And why did the technique vanish completely from the archaeological record? Beneath the sands of the Egyptian desert, in the necropolis of Saqqara, lies a subterranean labyrinth that presents a logistical problem entirely different from the open-air sites of South America. Inside the limestone bedrock, a series of dark, confined tunnels, known as the Serapeum, houses 25 massive containers carved from solid Aswan granite. The Egyptian Ministry of Antiquities records that the heaviest of these boxes, including their lids, weigh approximately 100 tons. They sit lowered into deep alcoves, hollowed out along the sides of the tunnel system. The official archaeological consensus identifies these containers as the burial vaults for the sacred Apis bulls, dating to the New Kingdom and Ptolemaic periods. The proposed method of transport into the underground chambers involves the familiar mechanism of wooden rollers, ropes, and the slow displacement of sand to lower the boxes into their final resting places. However, independent engineers who have examined the interior of these granite boxes note a stark discrepancy between the proposed primitive transport and the physical object itself. While claims of absolute vacuum seals have been debunked, the internal surfaces are polished to an incredibly high degree of flatness, and the internal corners feature tight, uniform radii. To achieve this geometry inside a dark, confined granite box requires the continuous application of immense, directed force and precision abrasive tools. The anomaly is severely compounded by the physical environment. The limestone tunnels barely provide enough clearance for the boxes themselves, leaving minimal space for the hundreds of laborers, massive wooden levers, and complex rigging that the standard historical models require for moving a 100-ton monolith. One box remains unfinished, abandoned directly in the middle of a subterranean corridor. It is trapped in transit. It demonstrates that whatever method was used, it was operating at the absolute margin of physical possibility in a suffocatingly tight space. If standard sand and rope logistics could navigate these 100-ton monoliths around 90-degree corners in subterranean darkness, why has no modern engineering team been able to model a successful, scaled replication of that specific transit using period-accurate tools? To understand the true limits of ancient engineering, we must look at what happens when a civilization genuinely exceeds the laws of physics. In the Yangshan Quarry near Nanjing, China, lies the largest partially carved megalith on the planet. Commissioned in the year 1405 by the Yongle Emperor, it was intended to be a single, massive stele. The base, the body, and the head of the monument remain permanently attached to the mountain. The Nanjing Municipal Administration of Cultural Heritage confirms the combined weight of these three components: 16,250 tons. The official explanation is simple, undisputed, and entirely correct. The project was abandoned because moving it was physically impossible. The Chinese engineers of the Ming Dynasty, despite having access to one of the most advanced pre-industrial logistics networks in history, realized that no amount of rope, timber, or human labor could break 16,000 tons free from the earth and transport it. This is the counterintuitive reversal. The Yangshan Stele proves that ancient builders were not magical. They were bound by the exact same physical laws of friction and mass that we are. When they hit the absolute limit of their technology, their projects failed. Yet, this documented failure in the 15th century makes the successes of earlier eras profoundly troubling. If the highly advanced Ming Dynasty, with its vast empire and sophisticated organization, could not solve the logistics of extreme megalithic transport, what specific mechanical knowledge did the builders of the 800-ton blocks at Baalbek possess 14 centuries earlier? If human capability progresses in a straight, predictable line from simple to complex, how do we explain the regression of heavy-lift engineering over thousands of years? We now know that the physical record contains objects of a mass and geometric precision that push the assumed capabilities of their eras to the absolute breaking point. We do not yet have a verified, replicated mechanical model using period-accurate tools that can account for the raising of the trilithon, the internal corner cuts at Pumapunku, or the mortarless joints of Sacsayhuaman. These sites connect to a larger, cross-cultural pattern of megalithic construction that appears to have operated on engineering principles that subsequently vanished from the historical record, leaving later empires entirely incapable of repeating the feats of their predecessors. What this tells us is not that ancient civilizations were more advanced than we give them credit for. It is that the distance between what they built and what we assume they could build is measurable, and the gap is real. The gap is in the physical record. It is not going away. If this video gave you something, a specific fact you will repeat, a gap you did not know existed, a question the evidence raised, that no explanation has yet closed, share it with someone who would want to follow the trail. Understanding what ancient civilizations actually built requires us to look at the raw physical data, stripping away both modern assumptions and fabricated myths. Leave a comment. Which of these 5 structures do you think exposes the largest gap between the official archaeological explanation and the physical reality of the object? In a future investigation, we will examine an ancient maritime mechanism recovered from a shipwreck that calculates celestial movements with a precision Europe would not achieve for another 15 centuries. Also, write in the comments where you're watching from. This subject reaches people in places I don't expect, and I want to know